In this video, I would like to explain about acid value. What is acid value? It is defined as the number of milligram of potassium hydroxide. The number of milligram of potassium hydroxide which are required to neutralize the free fatty acid present in 1 gram of fat. If we have 1 gram of fat, then how much potassium hydroxide is required to neutralize the free fatty acid present in that 1 gram is known as acid value. So, the number of milligram of potassium hydroxide which is required to neutralize the free fatty acid present in 1 gram of fat is known as acid value, and it is also known as neutralization number. And the acidity is an expression of the content of free fatty acid present in the fat or oil. So, it is the expression of the content of free fatty acid present in fat or oil. So, the acid value is defined as the number of milligram of potassium hydroxide required to neutralize the free fatty acid present in 1 gram of fat, and it is also known as neutralization number, and it is the expression of the content of free fatty acid present in the fat or oil. Let us discuss the procedure to find out the acid value. The procedure is, first of all, we want to take an accurate weight of the sample, that is fat or oil sample. Just take the accurate weight of the fat or oil sample. Then add 50 ml of ethanol and ether solution. We want to take this fat or oil sample in a conical flask. Then add 50 ml of ethanol ether solution to that conical flask. Then shake well. Okay, first of all, we want to take fat or oil sample in a conical flask. Then add 50 ml of ethanol ether solution to that conical flask. Then shake well. Then we want to titrate the solution with the potassium hydroxide solution. So for that, we want to take the potassium hydroxide in a burette. And the normality of the potassium hydroxide is usually 0.1 normal or 0.5 normal, etc. So we can take this normal solution, potassium hydroxide solution, in the burette, and then we want to add the phenolphthalein indicator, 2 to 3 drops of phenolphthalein indicator in the conical flask. Then start the titration with the potassium hydroxide. So we get a pink color. That will be the end point. So before that, it is a colorless solution. Then after the titration, we get a pink color. So that will be the end point. So we want to measure how much potassium hydroxide is utilized to get this pink color. That is the end point, and that is the measure of the potassium hydroxide. So first of all, we want to take the weight of the sample, that is fat or oil sample, and take it into a conical flask. Then add 50 ml of ethanol and ether solution and shake well. Then titrate the solution with potassium hydroxide by adding 2 to 3 drops of phenolphthalein in the conical flask. Then we get the end point, that is a pink color, and here we measure the potassium hydroxide used. How much potassium hydroxide is used to get the end point. By using that value, we can calculate the acid value. The formula for calculating the acid value is 56.1 into V into N whole divided by W. 56.1 into V into N divided by W. Here V is the volume of standard potassium hydroxide solution used in ml. Then N is the normality of potassium hydroxide solution used. Then W, it is the weight of the sample, that is fat or oil sample in grams. So this is the expression or formula for the finding acid value, that is 56.1 into V into N divided by W, where V is the volume of standard potassium hydroxide solution in ml and N is the normality of potassium hydroxide solution that we used. Then W is the weight of the sample, fat or oil sample in grams. Now let us see the significance of the acid value. It's used to measure the breakdown of triglycerides into free fatty acids. The breakdown of triglycerides into free fatty acids which has an adverse and undesirable effect. So, it is the measure of breakdown of triglycerides into free fatty acids which has an adverse and undesirable effect. Similarly, it is the measure of the degree of hydrolytic rancidity. It is the measure of degree of hydrolytic rancidity. Hydrolytic rancidity means the hydrolysis of fats with the liberation of one or more volatile fatty acids. The hydrolysis of fats with the liberation of one or more volatile fatty acids. So, it is the measure of degree of hydrolytic rancidity. And edible oils should not contain acid value greater than 1%. Edible oils should contain acid value greater than 1%. And the quality of fat and oil or storage condition is also checked by using the acid value. Quality of fat and oil or storage condition is also checked by using the acid value. Similarly, the pharmaceutical oils should not contain any acidity. The pharmaceutical oils should not contain any acidity. So, the significance are, it is the measure of breakdown of triglycerides into free fatty acids, and it is the measure of degree of hydrolytic rancidity, and edible oils should contain acid value greater than 1%, and quality of fat and oil or storage condition is also checked. Then pharmaceutical oils should not contain any acidity. These are all about acid value.